Hello everyone, I'm Bradley Sward, and this is my Day 16, Part 2 solution to the Advent of Code 2024. The problem is called Reindeer Maze, and I am solving the problem, almost as always, in Python. So, Day 16, Part 1 was you got a maze. It cost you 1,000 units, 1,000 shekels to rotate yourself counterclockwise or clockwise. It costs you 1 unit, one shekel to move in whatever direction you're facing. What is the shortest amount of shekels it costs you to get from the start to the end? I like the word shekel today. So the answer to part 1, if you do all the math, and that's a different video, at least for this video, it was a 7,000, and you get, what is it, 160,624. And so now for part 2, like always, all the fun of part 2. The fun of part 2 is, well, considering that you can actually get from point A to point B with the same score, but you can get there from 2 or 3 different ways. So the end goal is how many different squares make up the paths that are the best paths to get from point A to point B. So again, so basically every time something's equal, then you basically have a second path or a third path or a fourth path to get from point A to point B. And if I do this right, and they show you all the examples, of course, my answer is 607 or 692. And you can see that I get 692. So my program runs both part 1 and part 2 at the same time, simultaneously. It doesn't, so it's all done in one pass. The code is just kind of crazy horrendous, but let's just talk about it real fast here. So I have the directions I want to move. I have my closed list from before, because if I ever come back to a spot that I've already kind of exhausted, well, it's never going to be a better cost, because it's going to take shekels to get from wherever and then come back. So that's the whole reason why you don't want to continue. My code is slow as heck anyway, and that would make it ridiculously slow if we didn't have a closed list. But we do the stuff like before, but now for part 1, the difference between part 1 and part 2 is now to every position I'm adding a map, or a set, sorry. I'm adding a set of all the places I've been on that path, on that best path. That is the positions on top of the X position, the Y position, the rotation, and the shekels. I'm also keeping track of what positions has this path taken. I probably should have done that in part 1, but we didn't need to. So then what happens here is if I find a solution, if I find the end position with a certain position in the list, I'm done, because it's the best one. And so that's it. So it prints out the right answer. So but otherwise, for every time whatever the best position is, whatever's the least amount of shekels of the potential that I have in the moment, I go ahead and I say, well, let's pretend like I could walk in the direction I'm facing and add a shekel, and I go, well, does that, and then basically go, in that position, is this a better path? And I go, if it's a better path, well, then let's set it to a better path. But if it's an equal path, and that's the kicker here, then we're going to merge the two sets together, because both of those sets are equally viable options. And so we do that for moving forward, and then we also do this for rotating both ways. And I probably could remove this, because in my understanding here, you're already you're not moving anywhere, so I probably could, maybe that would even speed things up a little bit, but maybe not. Who knows? But anyway, so you try pushing forward and you try rotating, just like you did for part 1. And then with that extra understanding of how we basically access this set of positions, when you're finally done and you find the right answer, and this is where you sort everything frame by frame, there must be a better way to do that as well. Maybe an insertion sort or something better than just a sort, but whatever, it's all good. The answer is, the problem is solved. Now it's just a matter of engineering, right? But anyway, so to come back up, whenever you get to the solution, whatever that position, whatever that, I'll have an X position, a Y position, which matches the goal. I'll have the rotation, which doesn't matter. I'll have the lowest score, which is the part 1 solution. And then the length of the set is how many total squares are basically occupied by a best path, and then we can put our little elf or whatever the heck on the spot. So that's my solution here for part 2. It took me a while to get there, partially because, it's nighttime. Who wants to be up at 5, 6 in the morning doing these kind of things, or even 2, 3 in the morning? So anyway, that's my solution. Thanks for watching. I hope you guys have a good day, those of you watching, and I'll see you in future videos.